So the today's problem is invert binary tree. The invert binary tree problem states that given the root of binary tree, invert the tree and return its root. In this example given here, we have the root as 4 and it remains as it is. Now it has two childs, 2 and 7. Now in the inversion, what we do, we invert the children of them. So in the place of 2, the 7 comes, and in the place of 7, the 2 comes. And now let us take the children of 2. The children of 2 were 1 and 3. 1 in the left and 3 in the right. Whereas in the answer, it should be like the 2 has the left children as 3 in place of 1. And the 2's right child should be 1 in place of 3. We need to exchange or invert the children's. So let us look at the approach that how can we solve this problem. So the given here tree, we can see that the root as 4. And now we have the task to invert the tree. So first of all, we have the root 4. Then what we can do, we can take the left child and right child and invert them as we do in swap function. What we have in the swap function, what we do, we take in temporary and assign it to left or right anyone, and the left then is assigned to the right. The right has the value of left by using the temp. This swap function will also work here. The swap function first of all will work here for the 2 and 7, and the 2 and 7 gets exchanged. Finally, what we get is 4, 7 and 2. Now their children remain same as it is, because what we are doing, we are taking the pointers, means the addresses of this, rather than taking the value. So the children remain same as it is. Now what we do, we call the same function on the children's also. First we call this f function of this root, and now we move the root to this and to this. And the 2 has the children like 1 and 3. Let me draw it. So the functions are working on this and the children are inverted. So it becomes as 4, 7 and 2. The children of 7 are swapped, so it becomes 9, 6, 3 and 1 respectively. So you can see how we have made this tree as an inverse tree like this. So the algorithm is pretty much straightforward. We will have a recursive function, not an iterative one, because recursive is much simpler. Now on every instance, what we do, we call the function on a node, okay, and the children of the nodes are then reversed, are swapped, and then the children, when our children are swapped, we call the recursive function on the children's, okay, and then we again do the same for their children until we receive a null value, which is a stopping condition for us. So if the root is null or the node is null, then we stop our loop and then return the root, which is the, and finally we get the answer by returning the null. If 4 is in place of 4, what we have null, then what we are going to do, we are going to return it. If the children of 4 are null, let us say we have only a single node 4, then we have null and null. So the nulls are exchanging a null is a single step, so it won't affect much. And then after, when we call the function on the nulls, it won't affect. So let's implement the code for this. So we are at our code editor, and first of all what we need to do, we need to return the root if it is null. So we are going to check if root is equals to null, then what we're going to do, we are going to return root. The root is the node and not only the top child that we said. The root can be this also, this also, this also, and the children of 1 which are null also. So root in this sense is not only the 4 but also the every element. Now what we do, we are going to now perform this swapping function. So we will have a tree node, okay, that will hold the value of the left child, okay, the tree, and we are going to name it temp because it is temporary. So the root left, then the root left gets the value of root right, and then root right gets the value of temporary. Now what we do, we are going to call the invert function, invert tree function that is defined here, invert tree, on their children. Okay, so root left, root right. So this is the code, and finally we are going to return the root after performing this action. So it is first going to call on this, then on this, and then on this, and finally the answer will be returned. So let us test the code on the example test cases, and let's see it works or not. Yeah, it is working. So let us return it, submit it. Yeah, it is 100 times faster. That means it is very fast, it is very much efficient for this. And this was the solution for the invert binary tree. Thank you for watching this video. If you like it, please hit the like button, and if you have any doubt, please write in the comment section, and subscribe Programming Rush for more new videos. Thank you.